My name is Jared King. My fellow group members are Cannon Rudd, Elliot Nibley, Gabriella Goodman, and Tim Cottrell. We were sponsored by the kinesiology department here at the U and created a cross platform mobile application that can be used to take concussion tests and provide instant results. We did this by implementing the research that the kinesiology department had been developing on concussion testing. To do that, it was important to first understand some of the problems that were currently being faced. Concussions are a very frequent injury in contact sports. There are many tests to determine if an athlete has a concussion, but many of these tests require specific equipment. The kinesiology team realized concussions can be diagnosed by evaluating reactive balance, in addition to a few other mainstream concussion tests. They developed a concussion testing procedure that is extremely accurate when assessing if an athlete has a concussion, but there were a few problems with their procedure. They use 6 laboratory-grade sensors to accumulate data during a test, but most clinicians and athletic trainers do not have access to these. Their process for collecting data and viewing results was not very streamlined. It involved first attaching 6 sensors to a patient, then administering a test, exporting that data collected from the sensors to a computer, then running that data through a MATLAB script which would eventually output understandable results. Additionally, clinicians must be trained to administer these tests. Specifically, for the reactive test that will be shown later, it involves training a clinician to lean a patient back to a certain angle, and even then, there is a lot of variability in the angle a patient's leaned at. There are a few other concussion testing apps that aim to be what our app is, but none of them involve reactive balance, and that is what makes our app unique. Our solution to these problems were as follows. We created a cross-platform mobile application for increased accessibility, which allows clinicians to administer and record tests on a single device. Our app gives detailed instructions for how to administer the 3 types of concussion tests we implemented. Upon taking a test, you will immediately get results. To address the issue of variability when leaning a patient, we play tones when a patient is positioned at the correct angle. We store all data in a HIPAA-compliant way, and we have set functionality up to export patient test information should a clinician wish to view it on a computer instead of a mobile app.
Let's walk through running a reactive test. When you open up the UReact app, you are met with this login page. We provide the ability to sign up and log in to specific organizations. This allows you to only see patients associated with your organization. Once we are logged in, we come to the patients list. From here, you can navigate to any existing patient, or you can create a new one. Let's go to Jared's patient file. We have all of the crucial data for the clinicians here, and we're able to edit all of this as well. You'll also see 2 incidents, baseline and concussion. Currently, these are the only 2 incidents available to select from when you create a new incident. Let's go into the concussion incident. We can see that an acute test has already been ran, but it's been about 3 months since then, so let's make a follow-up test. One thing to note here is that from any concussion test, we have easy access to the most recent baseline that has been ran, so we can easily compare our results. Now, let's run a reactive test. When you're ready to run a test, you'll see this page. Ideally, you'll have a belt like this, and you can put the phone in the belt and attach it to the patient's lumbar spine. As you can see, there are directions on the left here about how to run the test, and all you have to do is press the start button to get going. Once the clinician presses start, they will get ready to hold the patient and bring them to the right angle. When the patient is in the right angle, a chime will play. It can be tricky to find the right angle, and we find that clinicians we work with are much better at doing it than we are. Once the patient regains their stability, the app automatically goes to the next page. Now what we're looking for with the reactive test is the time to stability. The time to stability starts when the patient was dropped and ends when they're stable for more than 1 second. Now, for someone who is not concussed, it will look easy, like this. For someone who does have a concussion, though, They will likely stumble over themselves, and it will take a little bit longer for them to regain their balance.
One of the main purposes of the app is to make the balance tests easier to perform and more user-friendly for clinicians. The first of 3 balance tests that we implemented is the reactive test, which you just saw. What we did here to assist the clinicians and make it easier is we help them find the right angle to lean a patient with audio cues. We automatically start and stop the accelerometer recordings when the patient is either dropped and when they become still. And we use sounds to signal that the recording is done and that the patient can move again. The second balance test that we implemented is the static test. To perform this test, you would strap the phone to or device to someone's back and then see how still they can stand with their feet together. We then just measure that and display the results as we do on the right side. Some of the improvements that we made to this process is we implemented an automatic 30-second timer, so we know when to start and stop the recording. And then we also allow them to run the tests on foam or solid ground and record those results. The final balance test that we implemented was the dynamic test. To perform this, you would again put the phone or device on somebody's lumbar or back and have them walk in tandem on a line for approximately 5 meters, turn around 180 degrees, and walk in tandem back to the starting point. The improvements that we made to this process and that the app assists with is we give the clinicians comprehensive instructions on how to perform this test. We also give active feedback about the validity of the results and if we need to restart the trial. And we automatically time the duration of the trial, which used to be done with a stopwatch separate of the sensors.
In the beginning, we knew that we would need an app that was both accessible and secure. We used Flutter as our front end. This allowed us to easily create cross-platform support and access the gyroscope and accelerometer to run our tests. We then created custom API calls between our Flutter front end and our backend, which we hosted on AWS. Our Flutter mainly connected to the EC2 instance that ran a Python server. The Python server had many functionalities. It ran the mathematical scripts that analyzed the data from our tests. It connected to an RDS database that allowed for us to store patient information easily. It connected to Secrets Manager, which allowed us to keep everything secure and organized. And it connects to Cognito, which allows us to create a secure login for our users that can be multi-organizational.
Now that you've seen the capabilities of our app, we wanted to share the next steps for our project. We will continue to refine the user experience of the app so that it will best meet the needs of clinicians and researchers. We will also continue to validate the results generated by our app with current testing methods. Finally, we will continue to perform user tests to get feedback as we iterate on our app. Finally, we would like to recognize and thank all of our collaborators listed here on the screen from the Utah Neuromechanics and Applied Locomotion Lab. This opportunity allowed us to create an interesting and useful capstone project, especially with their guidance and feedback. Also, this project was supported by the Pac-12 Conference Student Athlete Health and Wellbeing Initiative, with additional funding from the National Institutes.